And with that, we will move into our next talk, which is with Valerio Velardo. I'm sorry, I messed that up. It's a bit of a tongue twister. And
yeah, it's easy to mess it up if you're not Italian or I guess Spanish.
yeah, I speak decent Spanish though, but
Yes.
yeah, I need to work on it clearly. Yes, and thank you very much for joining us. Valerio joins as the creator of another YouTube channel, which is doing really well. It's called The Sound of AI, and it focuses on AI and sound, which is awesome. Very descriptive YouTube channel name, which is I've found is done very well. He's also been in the field for over 10 years and serves as a consultant for clients who are looking to develop AI-based audio products. And thank you very much, Valerio, for joining us today.
Yeah, thank you, Josh, for having me here. Yeah, it's really, really nice because like a year and a half ago, a little bit more than that, when I started The Sound of AI, like you were sort of like inspiration at that point, right? So it's
Amazing.
nice, like after, after a year and a half, then just like chatting together, like on the meetup. Yeah, that's cool.
Yeah, thank you. And it's amazing. That's really cool to hear. And it's also really cool that is the growth that you've had just over the past year and a half as well. I mean, you've nearly caught up to the number of subscribers that we have on the audio programmer, and I think that's great. And it's a great testament to the awesome stuff that you're doing over there.
Yeah, thank you for that.
Yeah, and I guess that would be a great place for us to start. Can you just tell us a little bit about the YouTube channel, about how you got the idea for it, a little bit about the types of videos that you do there, and a little bit about the concept behind the channel itself?
Yeah, sure. So as you said, the name of the channel is quite eloquent in itself, right? So the Sound of AI. So basically, what I cover the most is stuff that has to do with artificial intelligence and music, or artificial intelligence and audio. And I define it as AI audio. And here there are a bunch of different things which go from like speech processing to music processing, music generation, all of these sort of things. And the inspiration came at a point where like I basically like finished working on my like last startup, which was called Melodic, and then I decided to start like some like working as a consultant, and at the meantime I just wanted to, I would say, like give back to the community, right? So because up until that point I gathered a lot of experience both in industry and in academia, and I just wanted to give back to people. And I am like a big fan of open source, like the open source philosophy and all of that. And so for that reason, I started the Sound of AI, and there you can find things that are, as I said, like specific to AI and audio and AI and music, but also a little bit more general, like introductions to deep learning, but also like introduction to like audio signal processing from a machine learning perspective, or a music information retrieval perspective. So, which basically means just like using artificial intelligence and a bunch of other algorithms to extract information from music and other audio signals, and at the same time also using all of those algorithms to generate music, because that is one of like my big passions. And in terms of the channel, as you said, you have a bunch of like tutorials there, but you also have like content that has to do with like how to start a career in the space, and also suggestions, advice, and insights to companies which want to delve into AI audio, using AI like in their like audio products, right? And behind the channel, there's also a community, again inspired, which took like inspiration like from your community, right? And it has a Slack channel, and that like it has also like grown like quite nicely, like to more than 3,500 people right now. And like it's a very, very nice place where people help each other out. And as part of that, we also started a very nice like project. Perhaps we'll talk about this later on. That's called open source research. It's basically like bunch of people from the community working on a piece of research, really, that's like that builds like some open source software, and behind it we are also like putting together a paper that's going to be submitted to a leading journal in generative music.
That's fascinating, and it must be awesome for people that are looking to get into the field to have the opportunity to make a contribution to something that could possibly be published.
Yeah, I think like that is really, really interesting for many people. And so yeah, so organizing this type of project was a little bit challenging, I would say, because all of a sudden like we had more than 100 people. So if you add up all the people who like worked on the projects at one time or another, probably you have more than 200 people. And organizing all of those people to work on a paper, it's a little bit of a challenge, but we structured it in a way where we have different research groups, right, which focus on different parts of a project, which is quite modular, because at the end of the day, we're trying to build a sort of sampler that you can use to generate guitar sounds using some neural network technology behind the scenes, and then using your voice as an interface. So that's the kind of like catch like for it. And so like we had different groups working on different parts, someone working on the speech to text, someone else working on the sound generation, someone else working on the production side, right? And for each of these groups, we have like people who lead, the coordinators and co-coordinators, and then we have a bunch of other people who just like do the job, right? Do the research and do the implementation. And it's nice because you have people of very different levels of expertise contributing to the project and taking something beneficial to them. The people who are more experienced perhaps now are the coordinators, so they know also how, or they learn how to like lead a group of people, right? And at the same time, people who are like more beginners would be like kind of like I would say advised by other people who have more experience. So there's a little bit for everyone. And I found like that this idea of like doing research with a community is something really, really cool that gives a lot of opportunities to people and makes research even better.
That's really amazing. I'm very curious to hear a little bit more about the organization and how you actually organized a project that was so huge. So do these teams, do they work autonomously, or do they come together every now and then, or on a weekly basis? How does that work?
Yeah, we have a sort of hierarchical structure, I would say, right? So on the top, there's like myself and a couple of other, we call them like project managers, right? And so these are people who help just streamline the whole process, the organizational process of the project, right? And then below these people, we have the project coordinators. We have like one coordinator and one COCO, we call them, or a co-coordinator per research team. They have like their goals and they work on their goals. And then we have weekly meetings with the coordinators. So every Friday, I'd say like since last, I'd say like September or October, more or less, like we have a coordinators meeting. And initially, we also had a lot of community meetings where once in every fortnight or every month, we would have like all the community like joining together. Well, not all the Sound of AI community, but the people who are active in the project, right? And there we would just like provide information about like the current phase, what's going on, and what like people did, and what we have to do like for the next phase or stuff like that. And as I said, like it is like a quite challenging, but the cool thing is that what we found out is that at the end of the day, the project was modular enough for the different people to, or for different groups which have relatively manageable sizes, like from 5 to 10 people, something like that, to work more or less autonomously and then reporting back. So what you would have to do is just like coordinate like the higher levels, and then just like leave the implementation to leave the organization of each of the groups by themselves. And indeed, they also have research group meetings. So some of them like meet each other once a week, a couple of times a week, or once every 2 weeks, something like that. And sometimes you also have like cross meetings where two different research groups, or at least like their coordinators would align to share information and stuff like that, has like multiple dependencies. So in a sense, like we designed like this organization, if it, I would say like as if it was some sort of like modular code, modular system in itself, in order to avoid as much as possible the dependencies there.
Amazing. And I imagine that you must have some people that come into the project and some people that leave the project,
Yes.
some people that have more commitments at times.
Yeah.
How do you deal with that?
So the key is to have great coordinators and co-coordinators, right? People you can really trust, who will deliver. And now we have a team which is just fantastic. These are like people I really trust, and they've done like an amazing job. I mean, like for other people, as you said, like sometimes like there's new people who come in, people who just like lose interest in the projects and just like and they just leave. But that's fine as long as you have like an organization that's able to, I would say like these research coordinators who are able to I would say like provide information to the newcomers, and then just get them up to speed with what has been done and what needs to be done, right? And initially we also had a quite good way of handling all of this, where we had like a way of like keeping track of all the people in the different groups, and if someone like leaves, then the research coordinators would ask us to just like open up a vacancy, really, right? And then having other people from the community joining in. But we noticed that the more we got into the project, and the more difficult it was like for people who weren't there since the beginning or since an earlier stage to get in, because of course a lot of things like have happened and it's difficult to catch up.
Wow, that's incredible. And how are you still holding a day job at the moment, or are you working on the channel full time now?
Oh no, I'm still not working on the channel full time. That's something like that I really love doing at some point.
Mhm.
But right now, like I am kind of like juggling a lot of things. The channel, of course, and it's the thing that I really love the most. Doing like some research on the sidelines, like for my personal things, and then doing like a main consulting gig with a company that's called Museum Up, where like I work as a senior data scientist there, and doing a bunch of other like consulting gigs here and there, like with companies like from all over the world, from San Francisco to like European companies and stuff like that. Yeah.
That's awesome. And can you tell us a little bit about what your consulting service is like? How does that work? How does that typically work when it comes to a company?
It really depends, because I offer different services. Like some of those are more, I would say, like hands-on. It's basically me developing like AI music or AI audio solutions. And it could be, I don't know, like a music recommendation system. It could be like a music search system. It could be, I don't know, like some noise reduction, AI-based noise reduction system, speech verification, stuff like that. So that is, I would say, like one path of action. But then there are also others which are more like strategic or mentoring, right? So for example, for a company in San Francisco right now, I'm kind of like sort of like mentoring the guys there, helping them out, also like setting the schedule like for or organizing like their workflows, and trying to like keep up also like with their scrums and stuff like that. So there's also like this aspect which is more like consulting based, and there's also like another part of it which is just you have like a problem like with an application that you or your team is developing, and then you just like come to me for like, I don't know, like getting like more insight regarding like that specific problem. So for example, how do we do I don't know, like genre music classification, stuff like that. So we tried this and this option or this solution really didn't work out for us. So what else can we do, right? And I could do research for you. I could just like mentor your teams and stuff like that.
That's awesome. So one thing that I've noticed in the field is I've seen companies that come out and they say that our focus is on machine learning or on AI. And I'm wondering your thoughts on that as a person who has a passing passing knowledge of machine learning and some of the basic processes around it. What I've always been taught and taught in university was that machine learning was something that was more of a how, or something that you would resort to as the way that you would resort to like a screwdriver or a hammer as a tool to solve a particular problem, rather than, okay, I'm going to do a job and I'm going to use this hammer. So I'm looking now for jobs where I'm going to use a hammer. What are your thoughts on that? Do you think that it's necessarily a good idea or a bad idea for a company to start off and say, okay, we're looking specifically at machine learning or AI focused audio problems?
Yeah, I think that would be completely detrimental, because if you can use an algorithm that's easier than machine learning, then you should definitely go for that, right? So machine learning comes into place when you can't use like heuristic-based algorithms and stuff like that. Actually, one great way of starting up like with a product that's also like in the AI or AI music space is to start from non-machine learning models and using like other sort of algorithms. So the whole point is that like machine learning in whatever field is extremely hard to get right. And it's one thing like to build a prototype that can work decently enough, and that's like something that a lot of people can actually do. It's another thing to take that model, that prototype, and put it into production. There's this chasm which is like huge. Now, what's the problem with starting like with the latest technology in machine learning? For example, say transformers or like VQ, VAE, so vector quantized variational autoencoders. Well, the problem is that it takes a lot of time also like to get the research right. So what you want to do, rather than starting with the state of the art, it's, if you can, start with an algorithm, with a solution that's heuristic based, which will take you up to a certain point that most of the time is quite decent. It's 80% of your solution, right? And then build the whole pipeline around it. And by building this, perhaps you're going to also gather data, which is instrumental to build solid, reliable machine learning solutions. And so in the first iteration, you build a very simple solution, or as simple as possible, as fast as you can. You build a pipeline, you acquire data, and then only from the second iteration, you start to use some machine learning solution, because now you can leverage data that perhaps earlier you didn't have, right? And again, you don't want to start with the state of the art, but start with something simple that, rather than taking you to 80%, will just bump up your solution to 90%, right? And then you iterate on that. And in the process, you're going to learn a lot of things. So to answer to your question, starting a company saying, I'm going to use, or I'm going to build like an AI audio product, doesn't make any sense. So you want to build it. If it happens that you have to use AI, then that's great. That's fantastic. And you're also going to have a fantastic buzzword to use with investors. But if that's not the case, then it's fine. It's even better because it's going to be faster.
That's great. And for people who may not be familiar with AI or machine learning, or just have a very casual interest in it, what really makes a problem a machine learning or an AI problem?
I'm going to give you an example. Take, for example, a genre classification, right? So you have a catalog, a music catalog with a lot of tracks, and you want to say, yeah, this track is rock music, this track is indie pop music, whatever like that may be, right? Now, the problem is that in order to build an algorithm in a sort of like traditional way that knows how to classify like this, these different genres, or just like to assign different genres like to different tracks, you would have to build like a very, very complex and sophisticated system with a bunch of rules. And at a certain point, the number of rules like becomes like so big that it's difficult to keep track. Like the whole amount like of rules makes it like completely impossible to maintain the system. And then it is at a certain point with certain tasks, it's really, really difficult to come up with rules that will allow you, like, for example, say, yeah, this is like a piece of music that's in a rock genre, or that's in a blues genre, just like only looking at the spectrogram, or perhaps like even like its waveform, right? And at that point, machine learning helps you out, because you have a sort of like inversion of the whole like designing process. In a traditional heuristic based algorithm, the typical software that all coders write, so you have like some rules, or you have like some logic that you as a human being write, and then the machine executes like what you come up with, so all of your rules. But in machine learning, it's the other way around. So you pass in some data, then you have like some sort of like magic box. Of course, there's a lot of like mathematical complexity in that magic box, but we can call it a magic box. And then the magic box, through some like sort of like statistical processes, figures out the rules for you. So you're basically like switching from a U code, you pass the rules in the software, just like uses those rules to a situation where you pass the data and the software figures out the rules for you. So every time it's impossible to figure out a solution for a problem because there are too many rules and it's difficult to create those rules, then machine learning makes sense.
Very interesting. I want to go back to one thing that I think about a lot when it comes to machine learning, which is genre classification. And I was curious because I imagine you must have a lot of experience with this. And I'm wondering what the state of the art is at the moment on genre classification, because one thing that I think about a lot when I'm listening to Spotify or SoundCloud is that, and this is probably one of the first things that any researcher would think about, which is a person may have a song from a certain era that may have a certain spectrogram, certain type of music, certain tempo, and all of these certain instruments and sounds that are used. And then they listen to another song that has the same instruments, same characteristics, but they don't like that song because it's so tied to maybe what's playing on the radio or a certain time in their life. I'm wondering how are researchers trying to tackle this problem at the moment?
Basically, I would say like we are tackling it, throwing at a problem a lot of like convolutional neural networks or some sort of like variation on the theme of convolutional like layers and stuff like that, and it works actually quite well. So but there's a problem with this sort of like music classification problems, which is that there's an element of subjectivity there, right? So if you and I were to classify or genre classify a piece of music, depending on our backgrounds, depending like on our lives and our listening habits, we would probably not always agree on the way we classify those tracks, right? So you may listen to a piece of music and say, yeah, for me, this is indie rock, right? And for me, perhaps it's just rock because I don't listen to a lot of rock music. So I don't have a very granular understanding of the genres and subgenres, right? Perhaps because I listen to a lot of classical music, for example, right? And this is a problem that machine learning doesn't magically solve, right? So there's one thing that we use in machine learning in any field really that we use as sort of baseline, which is it's called human level performance, right? So we aspire to arrive at human level performance, right? And in certain tasks, certain machine learning, deep learning algorithms are even better than human level performance. For example, in speech recognition, certain algorithms do a better job than we humans do, right? Now, the problem with a task like genre classification is that there's a level of subjectivity. So there's a sort of like glass ceiling or for like this algorithms, right? So I would say like that we would agree, or like people would generally agree, like on genre classification, like to 70 to 80% like of the time, right? And somewhere there you have like this sort of like glass ceiling, right?
Yeah.
So it's impossible for these algorithms to do better than us, just because there's not completely agreement between two or more human classifiers, right?
Mm.
But this is also an interesting point, because a problem like genre classification or music emotion recognition depends also on the taxonomy that you would use, right? It's one thing if your taxonomy like is very, very high level. So for example, you have rock, blues, jazz, and say only like 10 genre labels. It's another thing if you have 100 genre labels, which are way more granular. There, of course, the so-called subject inter-agreement, right, or the level of agreement among like different races, which necessarily go down, and with that would also go down the so-called human level performance on those taxonomies for genre classification. So all of this to say that genre classification, just like music, emotion recognition, is a highly subjective task. And so you can't expect for an algorithm to respond to everyone's tags, or to all the tags that they have in mind in their way of classifying, right? And so there's this aspect which makes like this type of problem like even more difficult to solve because of this element of subjectivity.
Amazing. It reminds me of something that I saw in university in a machine learning course, actually, where it was a facial recognition algorithm, where what they do is if they have 50 faces that they're trying to identify, what happens is that they try to generalize one average face out of those 50 individuals, and then that's the general face, and then you have just kind of slight differences between those faces, because most people are going to have two eyes, a nose, and mouth, and they're going to be relatively located in the same places. So yeah, your description of genre classification reminds me a lot of that.
Yeah, and you can think of like that merging together all of those faces to have an average face as the exercise of a rating, of like giving tags or giving labels to tracks provided by many raters. Because at the end of the day, if you want to build like a solid enough data set, you want to have a lot of different ratings, so that at least the machine learning algorithm is not going to be completely skewed towards one rater, like one human classifier, right? So you want to get a sort of, I would say, like average of those ways of like classifying of those strategies. Yeah. Now, the cool thing is that if you think that it becomes difficult with a process like with a task like genre classification, the thing becomes even harder with something like music generation, right? Because there isn't really any right and wrong, right? So when you have a type of algorithm, for that matter, that generates music, so who's to say that's bad, right? So that there's this element of completely incredible subjectivity that makes the endeavor of generating music through machines even harder, because there's no baseline there. You can't say this is good music, this is bad music.
Mm. Yeah, and there have been some pretty compelling music generation projects that I've seen. Things like Biggie doing like Frank Sinatra lyrics, or vice versa, things like that. Pretty awesome. One question that I've had is, I know that there have been legal disputes about that, and ethical disputes on if it's something that imitates Biggie's voice, but in reality, it's not Biggie's voice. It's based on Biggie's voice, but it's not actually his voice per se. Where are we in terms of the legal argument for that? Is that still something that is still going back and forth, or has there been a conclusion to something to that?
At the moment, there's a sort of legal vacuum, if you will, right? Because it's it's very, very difficult to provide sort of authorship like to this music that's generated by these algorithms. Who's the owner there? So is it the programmer? Is it the neural network itself? Or is it the somewhat shared ownership across all the training data that you used? And so in reflection, I would say like the ownership will be that of the authors like and the producers of that music. So it's still like something debated. I don't think like it has been solved, and it's more of a philosophical problem, I would say, than a like scientific one, because like it's very, very, very difficult like to draw a line and say, yeah, the ownership is like 65% to the developer, and I don't know, like the remaining part to the data that we used, right? But yeah, this is definitely like something like really, really interesting, and it shows you how like technology draws ahead also like conversation in other fields, like for example like the legal fields, because at the end of the day we'll need to sort of provide a legal framework to this, but it's still like in the making because we still don't know where we're going to land with this technology, right? It's very, very new. Well, not the technology, because we're generating music since the 50s or mid 50s, I would say, right? But this quality of music generated and this sort of impact that it has had on society has never been seen before. I would say like it's been manifested over the last like 3-5 years, not more than that.
Yeah, absolutely. And in terms of generative music, so I've seen a couple sites that have done things like generative music beds, things like that. Where do you think that is heading now? Where are the trends heading for generative music? Are we going to hear generative music on the radio in the future? Is that something that's going to be a thing?
Well, to be honest, I hope not, because we have a lot of human musicians who are just fantastic. So I wouldn't go in that direction. And indeed, also like when I was working on Melodrive, my startup, old startup, well, we were working more with this idea of providing tools for musicians to be more creative. And in particular, I think there's a big opportunity in interactive music or music for video games, because there you have a music which should change a lot depending on the gameplay, right? And so different players are going to have a different game through and or a different gameplay, and so depending on the decisions that they take in real time, the music should also change, just like the narrative changes or the visuals change. But right now, like this is like done, but done relatively poorly, I would say. Now, what AI could actually do is create a sort of infinite version of a musician, of a composer, and then creating music that adapts in real time based off some sort of scripts that the musician created beforehand. In that sense, you can think of an AI as a sort of facilitator or enabler. So you as a composer create a music script, and then the AI implements it, for example, with different instruments, with different harmonies, or with different emotional context. And so this is where I'm hoping AI or generative music will go towards, but I'm definitely like hoping it won't go in the direction, okay, so we're going to just like replace musicians. Now, I think like this exercise will be completely useless, and it's not going to work, for a simple reason, because like we don't listen to the music of one artist just because we like the music per se, but we also like the artist, and we are fans, and we have this sort of human relationship, fun relationship, like with the artist. And this doesn't happen with a machine. We don't care, right? But what indeed can actually happen in terms of so-called linear music is that a lot of the functional music, say for example, music for advertisement or music for YouTube videos, may actually be replaced by machines. And there I see like a big market that generative music can conquer in the early future.
Yeah, that's really amazing. And as I'm sure you know, companies like Isotope have done a really nice job of employing machine learning in their plugins, things like RX8, which is a denoiser, noise isolator. Also, we've seen it with DJ software as well, where people have used the Splitter project from Deezer successfully to isolate stems from in instrumentals. And I'm wondering what other interesting things you're seeing in terms of what people are making for plugins or for audio applications. Where's that going? I see a lot of MIDI generators, chord generators, those types of projects. Is there anything else, or has that space been fully explored?
No, I think it's been explored at the moment, and I think like there's a lot of opportunity there, and I see like different types of applications there. So one is more assisting producers, for example, like some sort of intelligent reverb, and I think like Isotope also has that, right? Or some sort of intelligent automatic mastering, like Lander is like the biggest example that comes to mind here. So in that respect, I think we're going to see sort of like all your plugins that are going to employ machine learning, because that's going to just streamline the user's work, right? You're going to get like a quite good result. Of course, then you can tweak the results. And I think like that's the whole point of assistive AI technology, AI music technology. So you get a sort of algorithm that takes you to a very good point. And then if you want to just like put your own touch, for example, as a mixing engineer or a mastering engineer, you can do that, and you should do that. But that is also going to like offload a lot of like the sort of like annoying work that like people have to do like on this sort of productions. Now, there's also like other plugins that I see that have a lot of potential. There's one like that I really love. It's called Atlas. I don't know like if you've seen that, but it's basically
Oh yeah,
right.
yeah. That's Matt Algonaut, right?
I don't know. Sorry, I'm not familiar like with the guys there like personally, but
yeah. His
no,
name, I think his name's Matt Algonaut. I believe his name is. He's amazing. Well, that's with the sound classification, correct?
perfect.
Yeah.
And that is a slightly different sort of problem, because it's not like music classification. You go like a few hierarchical levels down to the level of like atomic sound, right? But it's sound classification in the end, right? And it's not just sound classification, but in that particular application, I think it's for, or VST, I think it's for drum samples, right? So it just like organizes and separates out like all of your drum samples that you may have on your hard disk. But the great thing there, it's also the interface. So the interface, it's something that I don't think has been explored enough. So machine learning powered interfaces. So Atlas is an amazing product, not just because of the AI, but because of its interface, or the way you have like this sort of synergy between the algorithms and the human-machine interaction through the interface and the GUI, which is really, really cool, because you can find drum sounds that are very close to each other, which are also close in this cool three-dimensional space, right? So that is something really, really interesting. And now talking about like another project that I think like it's really, really cool. It's the Magenta Studio. So Magenta is this sort of research branch by Google where they experiment with creative AI. And one field they are experiencing or they are exploring at the moment is music, right? And so they have this switch that can be used as Ableton plugins. And there you have a sort of continuator. So you start a melody, and then that melody like continues, right? It's you have like that sort of generation, or you can just like come up with a melody line and then ask for an accompaniment, for example, drum and bass accompaniment or stuff like that. So this is like something that I find very, very interesting, because you have the machine that is in the creative loop, but it's not replacing it. And this is like the point I think like it's super important. So we should use AI to streamline our processes as creative people, and at the same time to open up possibilities. The example of the video game composer, right? So as a video game composer, you can't possibly write 1,000 hours of music or just sit or live in the video game and change the music in real time. But an AI can do that for you and can open up possibilities that before weren't just at all possible. And so, yeah, I would say like there's a lot of interesting things like to explore in this space. Something has already started and I see it. Other things will come in the near future for sure.
Yeah. And one thing that's so fascinating to me is that, at least when I was going through university, most or all of the algorithms were actually written in the 50s and 60s by people that were mega geniuses, and that it wasn't until recently that we actually had the computing power to actually do the calculations that were necessary to be able to do these algorithms. I'm wondering if that's still the case, or if people are starting to come up with new ways now, or if we're still really just doing variations on what our fathers and mothers built for us in the 50s and 60s.
Yeah, I would say that the foundations were provided in the 60s, 70s, 80s, right? So all of those like amazing neural network algorithms like back in the day. But as you said, so because like if you want to have like very powerful deep learning models, you need a ton of data, and it was just unfeasible to acquire that data without like our economy based on the digital, based on like the internet and this kind of stuff, right? But to answer your question, right now we are definitely sort of like building on those foundations. Of course, we are pushing forward and forward, and we have like new architectures, like for example, like the transformer, like that's like quite recent. Like I would say like initial foundations are always the same, but we are like pushing always, and this is amazing, because like at the end of the day, like we are solving problems with ideas which come like from our fathers and grandfathers, but we are pushing those ideas to their extremes, which is super cool.
Absolutely. One thing that I learned while I was at university, once again, was that for some to employ machine learning sometimes in an application or in a plugin, you don't necessarily need to have loads and loads of data. One thing that comes to mind is a tool called Wekinator by Rebecca Febrink, which I'm not sure if you're familiar with or not, but it allows people to actually be able to do simple machine learning algorithms actually without needing to necessarily be able to do any coding at all. It's a codeless tool, and you can actually pick it up and do it really effectively. And come up with some pretty compelling results. And she's done a lot in this field for sure. I'm wondering if you have any recommendations for people in terms of getting started, any courses that would be helpful for people, particular videos on your channel, particular people to follow. Any thoughts on that? I know Gene Kogan was really big on creative machine learning, doing style transfer algorithms and really fascinating things like that. What are your recommendations on that?
Yeah, so if someone is interested in audio and music AI, then I would definitely suggest the Sound of AI, like my channel, of course. And there are a couple of pillar series or courses. One is called Deep Learning for Audio with Python, and there, like I really start like from the start, right? So building a simple neural network like from scratch in Python, all the way to convolutional neural networks and recurring LSTMs, like other like sort of like architectures in there. I also happen to work with music genre classification. So that is definitely like one course. The other one is audio signal processing for ML, machine learning, because that is going to give you all the foundations that are necessary, like in terms of like all audio features, what they mean, what we can do with those, like for example, spectrograms, MEL spectrograms, MFCCs, this sort of things. And then, unfortunately, I would say that there isn't really that much in terms of like audio and music AI specifically. So this is something that you have to sort of pick and choose that from many different sources. But what I would definitely suggest is starting like with some sort of like application first, but then digging into the math behind, because without the math, you really are not going to understand what you're using. So you have a super powerful sort of like technologies and algorithms, but then you really don't understand how they work. And by not understanding, it's going to be really difficult for you to trick them in order to arrive to achieve your results, your goals, right? And in that respect, I would definitely suggest people to start picking up a little bit of linear algebra and this sort of things like statistics, probabilities, and sort of things. I would say go to the Sound of AI channel, start there, and then also deepen your knowledge across like different resources as well, like books on DSP, books on AI, and things like that.
Absolutely. I'll do one more question. I'm sure we got a million questions. I just see the chat going like crazy. So one more question, and then we'll turn it over to Teamer for the chat. So what's in the future? What are your ambitions for the Sound of AI for the YouTube channel? Where would you like to go? What would be a great accomplishment for your channel or for you?
It's an interesting. Yeah, it is a really interesting question, right? So I had this open source research project, right? The open source one, right? And we are almost towards the end of it. And this is something that worked out really, really well. We built an amazing, like, smaller community in the community, right? And I think I would definitely like to keep pushing on that side, so exploring this aspect of open source research and having community-driven research. I think like this is something amazing. And in academia, there's sort of resistance to that because, of course, in academia, you have like publish or perish sort of paradigm, right? Whereas here, it's way more like sharing information, helping each other out to like become better researchers and better developers, right? And so this is something that I have in mind. So how can I move like this initial sort of like prototype project to the next stage? But I don't have an answer to that yet. In terms of the channel per se, yeah, I think I'll just like keep pushing on sharing knowledge, sharing content as much as I can. I do want to address more the part that sort of bridges the gap between research and production, because I feel this is really where I see a lot of gaps, a lot of problems. And as someone who, for example, tried to hire a lot of people like for his company and also like for other companies, I realized that this is like this huge chasm. People who are really good researchers, but we're not really good at like production, machine learning production, right? Yeah, just like creating that bridge between those two elements, because I think like that is going to give like people a big competitive advantage whenever like they submit an application for a job.
That's incredible. That's incredible. Thank you so much, Valerio, for your time.
Thank you.
And now I'm going to actually turn it over to Teamer. I'm sure Teamer has a bunch of questions for us. Take it away, Teamer.
Yeah, thank you so much, Valerio, for all this fascinating stuff. And thank you, Josh, for asking all these questions. I really enjoyed that. I'm going to follow up with a few questions from the chat. First one was from kind of earlier in the chat when you were talking about genre classifications. Right. So Gareth Wong is saying, maybe mood and valence classification from engineered features can aid in the task of genre recognition.
Yeah. So I'll try to decrypt what this means, right? So basically, like we represent, there are many ways you can represent mood, right? So you can use labels, like for example, saying happy, sad, right? But you can also put it on a 2D sort of graph or space, right? And so one axis will be called valence, and it's like the sort of like positive, negative mood. So happy is positive mood. It's negative valence, sorry, guys. And then you have like the other axis, which is arousal, like, or energy. So by having like the combination of these two axes, like one point on this two-dimensional space will provide you like information about one particular mood, right? So it's basically a pair of valence and arousal or energy, so positivity and energy. So the question goes like this. So what if I inform my music genre classification using mood information through valence and arousal, right? So one sort of mood representation or encoding. And the answer is yes. You can definitely use that, and it can help out. But the way like things go right now is using directly like spectrograms, and then the hope is that your deep learning models are going to figure out like all of those patterns by themselves without you adding extra audio features or like mood features. So those things are, those like extra features would be somewhat redundant because they should be captured already by the deep learning model. So yeah, you can try it out perhaps as a sort of like pre-processing or post-processing, I would say, but then the main algorithm probably would still work better with only spectrograms or audio waveforms. So I hope like that answered the question. It was a little bit technical. I hope like I made it as clear as possible.
Yeah, thank you so much also for actually explaining the question before you got the answer. I think that was very helpful. Another question from Max Wally. How does the accuracy of real-time audio AI solutions, such as security systems based on audio event detection, stack up to offline AI solutions? And they're saying, I know that there are problems with the speed of complex algorithms and getting enough audio data to perform accurate detection, but how well do current systems overcome these problems?
Yeah, of course, you have a trade-off between real time and accuracy. So if you want to do something in real time, you need to have models that are lighter, less complex, and with that comes less accuracy. So that you'll always have this sort of trade-off. But the reality is that with that sort of problems, like for example, audio or sound classification, so like hearing, for example, the sound of a siren, like of the sound, like of some shots like fired, right? It's a type of task that you can do with convolutional neural networks that luckily are quite lightweight by themselves. So all of this means that you can find quite accurate solutions which fairly I would say like complex like architectures, but still running them like quite still having like some sort of like light computation. So yeah, of course you're going to trade in the real-time situation, you're going to trade like some accuracy for like speed, but at the same time it's not going to be like that much. But then of course it's difficult to say beforehand for all of these problems. You just have like to try them out because there isn't a formula that you can apply that's going to solve all of these problems.
All right, thanks. So said is asking, wouldn't you use affect as the ground truth for sentiment estimation instead of genre recognition? And affect is spelled A-F-F-E-C-T.
Right. Instead of, can you read that again?
Wouldn't you use affect as the ground truth for sentiment estimation instead of genre recognition?
Yes, of course. But these are two separate problems, right? For if you're doing genre recognition, then your ground truth are going to be genre labels. So in other words, you're going to have like a data set, and for each track, you're going to say, okay, yeah, this is rock, this is pop, this is blues, this is classical, right? But that is another problem. So sentiment analysis, which we don't call sentiment analysis in music, but we call it music emotion recognition. There, of course, the ground truth could be either categorical, so you would have mood labels. So for example, yeah, this track is happy, this track is sad, or it could be that valence arousal pair, right? So for each track, you're going to have like one value for valence and one value for arousal. You can go more granular than that. So for example, you could have a valence arousal curve throughout the track so that you have 1 point at each like second or 10 seconds, something like that, so that you have information that's more granular. But yeah, it doesn't make sense like to use genre ground truths for music emotion recognition. No.
So I actually have a question myself now, because there is another thing you might want to classify, which is, I don't know, how does a sound feel? Maybe like some people would describe it as warm or cold or something like that, right? And I remember that this is something that people actually severely disagree upon sometimes, you know, even much more so than with genre. Someone might describe the same sound as this is kind of warm and fuzzy, and another one person would describe the same sound as like kind of cold and harsh at the same time. So how do you deal with things like that, where there just isn't a ground truth really?
Yeah, I would say the closer you go, like I would say like this is a problem that we actually had in the open source research projects. So there we were trying to create this sort of ground truth where we would have like different sounds, like different guitar sounds, and then attach to them different labels, like for example, warm, fuzzy, distorted and something like that, right? So there are certain labels which work well enough, but others that are very, very subjective. So the solution that we had in that project is try to use labels that are more technical, like for example, slow attack or fast attack, things that producers would be able to understand better, and then sort of like translate like that level to an internal like semantic description that we had like of the sound, which was based more on like semantic labels like a worm and stuff like that. But to answer your question, the sort of like the more the farther you go from the level of the sound, the technical level of the sound, and the more difficult it becomes for people to agree on those semantic labels. And this is something that we actually like studied like in this open source projects.
So basically you're saying that like warm or cold aren't useful labels, and you would use something like many low mids, or like, you know, harsh, like peaks, resonance peaks, something like that, like those kinds of labels, right?
Yeah. Well, not all of those semantic labels, because like warm sound or like a distorted sound, these are things that people tend to agree more or less, but there are like other things. Like for example, I remember back in the day, like composing some music like for a video game. So I had like this developer who asked me like music that sounds like colder, or music like that sounds like ice, or stuff like that. And of course, like this was like his projection of what ice music would be, right? So because like not all the people like in the world would agree to what icy music would sound like, right? So the sort of like the farther you go from the technical level of the sound and how like it's composed and synthesized, and the more difficult is for like people to agree on. But still, there are certain conventional labels like worm or like fuzzy or distorted that still like within a certain community, like for example producers, is I would say like it's quite shared. Like there's a certain level of agreement there.
Okay, thank you. So there's two more questions from the chat. So the next one is actually, I think, quite interesting. So it's like a comment from Beats Bustin, and it relates to something that you said earlier in the discussion, where we were talking about, you know, whether people would listen to, you know, generated music on the radio, and then you know, we were saying something like, we listen to music because of the artist, and you know, this doesn't happen with the machine. And so the comment is, shall we then ignore Hatsune Miku? And those who are not familiar, it's like a synthesized voice, like an anime style avatar performing live on stage, kind of as an animated projection. And she's very popular, like in Japan, for example. It's not strictly an AI, right? It's just, it's kind of a voice synthesizer that's written, like performing songs written by humans. But I think if people can be fans of this kind of artificial avatar synthesizer voice thing and go to concerts, why wouldn't they do that with like something that, where even the song is generated by a machine? I don't think that's kind of completely out of the, you know, I think it's not unthinkable, you know, if Hatsune Miku is a thing, you know.
Absolutely, Hatsune Miku is a thing, but it's a thing also in a specific geographical place. I would say there's also like culture that comes into place, right? And like different cultures are gonna respond differently, like to I would say like to different stimuli, right? And I'm assuming like that it's going to be way easier for Hatsune Miku like to be popular in Japan than it could be like for Hatsune Miku like to be popular like in the States or like here in Europe. Like that's just like my completely like unqualified guess, but that's it. So, but for coming like to the interesting aspect there, I think like it's definitely possible to create a sort of like AI artist, right? So that like creates the lyrics, is active through some NLP algorithm, like on social media, and who will respond to you and all of that. And it's definitely possible, right? But at the same time, I think like there's like this sort of like relationship, like human to human relationship that comes into place when you are like following an artist. It's going to be like very difficult to replicate with a machine.
I mean, this is
would
like
say,
gets very philosophical at this point, right?
yeah.
It's all
Of
about
course, like I can't like test that out like right now because that hasn't happened, and I don't have data to back up my my statements here, right? This is just like a qualified opinion, I would say, right? But at the same time, if you think about what happened, for example, in another field, which is like completely different, but has some similarities like chess. So in 96, we basically saw Deep Blue, which defeated the Garry Kasparov, the chess world champion like at the time, right? And the interesting thing was that like people thought, okay, is this the end of chess? Well, it's not the end of chess. And now we have computers that are like years ahead of humans. They're way more capable of playing chess than we are. But still, we do play chess because we enjoy the human to human or human against human confrontation. There's that aspect there which makes chess creative, right? Which still fuels us to and pushes us to play chess.
And I think the important thing is that we don't just play chess. We also watch other people play chess. Right? We don't pay money to like watch AIs play against each other on live TV, but we do that with humans, right?
Oh, that's correct. Even though here I have I'm a fan of chess, right? So I follow like a lot of like the tournaments and stuff like that. And there's one algorithm called AlphaZero, which is this reinforcement machine learning based algorithm that plays chess at an incredible level and came out with a style of play which was super creative, felt completely human, sort of like romantic chess style, sacrificing stuff like for like speed like of play and initiative and stuff like that. And there I found a lot of grandmasters and people like me who are amateurs, like in beginners, like in chess, just marveling at that. And I would actually like watch that and just be completely in awe, right? But that doesn't mean that when it comes like Sunday time, I'm not going to watch like Carson playing against Nakamura, because like there's like that tension, that human aspect that makes it even funnier and better to watch.
That is really, really cool what you're saying about chess. I think that there's like a lot of parallels with like music here as well. There's this kind of creative process, yeah. And let
me add one thing on top of that, which is now what happened is that human players are playing AlphaGo style moves, which basically means that like the machine learning played chess style is sort of bleeding into the human chess style, which is amazing. And this is like what I'm
really
hoping
interesting.
Yeah. So I don't know, like who of you like is familiar with this, but like there's this like crazy move like in chess, h2 h4, like is the rightmost like pawn, like in the one like that is like in front of your, just like I would say like right to your king if you show castles, right? And that pawn gets thrown to h4, just like advancing in the squares and attacking. And this is like a move that has been played time and again by AlphaZero, whereas beforehand it was played by human players, but way less, statistically less than right now, because they found out that this is like a really cool long-term strategy that pays off, right? So here we have strategies and high-level concepts which come from the machine and entered the human space. And this is what I'm hoping is going to happen with machines as well. So if I can just like unthink here. So in my PhD thesis, I was working on this algorithm that generated like a rock music, right? And you had like a sort of like society of virtual rock agents, which generate rock songs and then evolve their musical style based on what they listen to, produced by the other agents of that virtual society, right? Now, the thing that I would do is started with some parameters that would create some sort of like very mainstream rock music, but then the parameters which like change, and then the music produced would be like super weird in the end, right? And there I was exploring like this sort of like possibilities of like rock music, like the space of rock music, what's possible, what makes rock music, right? Now, the cool thing could be like to find that region of the space where music is still interesting enough for us, but it's not what we've come up with up until that point. And perhaps by using this sort of like machine-based exploration, we could sort of enlarge our own musical and compositional spaces. And this is
so that is like so cool.
Yeah, that's
so because it happens in just one last comment on this, like it happens in music, right? That there's like a new band or a new artist that does something completely different and basically invents a genre by just being different. And basically you're saying that the same thing could be seeded by machines rather than artists doing groundbreaking stuff.
So you could use machines to brute force a lot of music generation, and then a lot of that would be probably completely garbage, but for you human, but not perhaps for damn machines, right? Because at the end of the day, there's also like the question regarding like who's the ultimate evaluator like for that music. But still, if we want to just like throw away most of the garbage music, still we would find some interesting music which is at the boundaries of the horizons of what we've tried out and what we can appreciate with all of our like biological and human constraints.
That is really cool. That was okay. After this massive kind of tangent, there's one actually last question on the chat, which is getting back to like the original topic, which I'd like to ask you. So George Conturas is asking, what do you think about using AI for hardware emulation?
Sorry, say it again. I couldn't get.
What do you think about using AI for hardware emulation?
Hardware
emulation, yeah.
Right. So I'm not an expert in that. So like my answer is not going to be like qualified. But I think like it's definitely like something like that. It can be tried out. So the cool thing is that like we are using, for example, AI also for doing things like that are like really interesting and at the same time like very difficult to do with other algorithms. Like for example, autonomous cars. Right now in autonomous cars, actually we do use simulated environments like and stuff like that, right, where we train our models, our autonomous like car models on those simulated environments. All of this to say that like there may be like an interesting like relationship like between like a simulation like an AI, both like for on the level of using simulation, for example, using an engine like a Unity for creating a sort of like environment and then doing some sort of like reinforcement learning there for like autonomous like driving or other stuff, other tasks. But still the other way around, using AI for like simulating like physical like hardware and things like that. But again, I'm not an expert on this, so please like don't take like my words on it, because yeah, that's not my field of research and interest.
All right. Well, thank you so much, Valerio. That concludes the questions and comments that we had from the chat. Yeah, such an interesting discussion. Thank you so much. This is really quite inspiring stuff.
Thank you, guys. Really, it was really, really great to be here, like, and chat with you tonight.
Yes, thanks so much for joining us. And yeah, two very inspiring presentations and talks. And I'm really excited about where audio is heading in the future. A lot of excitement, and it's so cool to see not only that the technology is moving forward, but also sharing is moving forward as well, which I think is really exciting with open source projects. Nick, with what you're sharing with Elementary and what you've done with React Juice, I think it's really exciting and a great motivation for other people in audio development to hopefully open up their secret bag of tricks and share them with us and share them with the world. So so thank you so much for joining us and sharing with us.
Thanks for having me.
Yeah, thanks for having me too.
Yeah. Great. So so I guess before we sign off, once again, I'll thank the sponsors, Juice, Sonox, and Focusrite for their sponsorship of the Audio Programmer Meetup. Thank you very much for sponsoring. And you can join us again next month for, I believe the date is October 12th. I see Timur scrambling for his calendar. And
yes, it is. It's always the second Tuesday of the month. And next month, that is indeed the 12th of October.
Yes. So join us. We already have our speakers confirmed, and we will announce them very soon. And the other thing is just, once again, just talking about the Audio Developer Conference. So many of the people that you've seen over the past year with the Audio Programmer Meetup and in our community are going to be joining us in London, and many people are going to be speaking at the Audio Developer Conference, which will be in London, 15th and 16th of November. You can check out more information on audio.dev, and now you can purchase tickets. And if you're unable to attend, you can still join online, and there will be details on that. Teamer is dying to say something, so I'm going to let Teamer take it from here. So
no, just what we said earlier, that if you for some reason can't come to London, or you feel like still not comfortable with in-person interaction, given that there's obviously still a pandemic going on, then you can also purchase an online ticket, and you're not going to miss out on anything, because you're still going to be able to watch all the talks live on the stream. And you're also going to be able to network with other people, because we have a cool online networking platform there as well. So yeah, go to audio.dev, check out the schedule, which is also online, and get your tickets, and I'll see you in London or online.
Yes, we will see you in London. And before that, we will see you virtually at the next Audio Programmer Meetup on the 12th of October. Thank you to everybody.
In 4 weeks. Yeah,
4 weeks. Thank you to everybody who joined us. Thank you for the fantastic questions. Thank you to Valerio and Nick and Teamer for helping make this possible. And we will see you next time.
See you next time. Thank you very much.
Guys.
Bye.